Hello everyone, this is Mr. Bob, and this is a short little tutorial video that I put together talking about the basics of vectors and vector addition. So let's get started. So first, just a very quick review. A vector, we know, is something, a quantity, a measurement that has both a magnitude and a direction. We represent vectors with arrows, and these arrows show, obviously because it's an arrow, show a direction. So this would show an easterly direction, or if we're using the headings of a compass rose, 0 degrees, this arrow would show a heading of 90 degrees. And if we're looking in between, something like this is a 45-degree heading. So that's how vectors show a heading. And one more, just to keep in mind, this is 360-degree coverage. This would be something just below 270, between 180 and 270. So 180 plus 45 is about 225 degrees. So that's the direction this vector is headed. Okay? First thing to remember. Next thing to know about vectors is the way vectors show their magnitude is by the length of the arrow. So you always want to set up a scale, and you want to make sure your scale is explicit. I'm just going to say here a scale 2 centimeters equals 1 meters per second. Okay, I just made that up, and obviously you're going to want to make your scale much more exact than I can on this application. But if I have that scale, then if I make a vector that's about 2 centimeters long, at least as I'm looking at it here, this would be a 1 meter per second at 0 degrees vector. Okay, and if I make it twice as long, say like so, and in this direction, this would represent 2 meters per second, and since it's the reverse direction, that would be at 180 degrees. So that's the second thing to know about vectors. The magnitude depends on the size of the arrow itself. Okay, so now we're going to talk about how do we add vectors in a way called graphical vector addition using a tip-to-tail method. And graphical means we're just going to use graph paper and draw the vectors out on a graph grid and add them that way. And tip-to-tail method refers to the fact that vectors have two ends to them. The end that has the arrow right next to it is called the tip, and then the other end without the arrow is called the tail. And we'll see here in a second how that plays out when we use this method. Okay, so let's start with a sample problem. I have two vectors here, two velocity vectors. Vector 1 is 3 meters per second at 0 degrees. Vector 2 is 4 meters per second at 90 degrees. And I've defined my scale down here. 1 centimeter is 1 meter per second. So if I'm going to graphically do these tip-to-tail method, what I'm going to do is I'm going to draw the first vector from the origin in the direction that it's indicated and the exact length. So with my scale being 1 centimeter equals 1 meter per second, and each hash mark representing 1 centimeter, then this vector is going to be drawn from the origin in the direction of 0 degrees until I reach the 3 mark. And I'll draw that, and draw the arrow there, and I'll label it vector 1. Okay, now here's where the tip-to-tail method comes in, because what I need to do with this second vector is I need to add it to the first vector, and I need to do it in such a way that that vector starts out at the tip of the previous vector. So vector 2 is going to start out at the tip of vector 1. Well, the tip of vector 1 is right here. I've just identified it with this green arrow. So I start vector 2. Let me change colors here. I start vector 2 at the tip of vector 1, and then I draw it in the direction of vector 2, which is 90 degrees. And so I'm going to draw it up, and I should have first laid out my scale this way, 2, 3, 4. Oops. Okay, and so what I'm going to do here is I'm going to draw up all the way until I get up to its length. And so this is vector 2. Stop. Okay, so I've got vector 2 here and vector 1. And so now what is the resultant vector? Because that's what I'm really looking for. What's the resultant vector that happens when I add these vectors together? Well, that vector is identified by starting from my initial starting point here that I've just put in purple and drawing the resultant vector towards the end of vector 2. So that would be drawn straight up this way and reach the tip of vector 2. And so I'm going to label this VR for the resultant vector. And the length of that vector is the magnitude, and the direction it's headed gives me the direction. Now I picked these numbers purposely because with this application I really don't have a ruler, I can't use a protractor on it, but I know that if this side of this right triangle is 3 and this side is 4, this is a special right triangle. It's a 3, 4, 5 right triangle, okay? And so this would be, the resultant vector is going to be 5 meters per second in length. And I just know, I would usually measure this with a protractor. I'm trying to measure this angle right here. I know that for this special triangle, this is a 53-degree angle, okay? But I would normally measure it with a protractor. And so there I've just added these two vectors together and gotten the result using the tip-to-tail method using graph paper. And that's it.